Welcome to Level 14 of 100 Paradoxes. This one is called the Two Envelopes Paradox, and it challenges the way we think about logic, probability, and decision-making. Imagine you're presented with two envelopes. Inside each envelope is some amount of money, but you don't know how much. You are told that one envelope contains exactly twice as much money as the other. You randomly choose one envelope and open it. Inside, you find $100. Now, you are given a choice. Keep the $100. Switch to the other envelope, which has either $50 or $200. At first, it seems like a 50-50 decision. But let's analyze it further. Since you don't know whether you pick the higher or lower envelope, there are two possibilities. 1. If your envelope contains the smaller amount, $100, the other envelope has $200. 2. If your envelope contains the larger amount, $100, the other envelope has $50. You reason that if you switch, there's a 50% chance you double your money to $200. There's a 50% chance you lose half and end up with $50. Now, let's calculate your expected value if you switch. 50% chance of $200 plus 50% chance of $50 equals 0.5 times 200 plus 0.5 times 50 equals 100 plus 25 equals $125. Since the expected value of switching is $125, which is greater than the $100 in your hand, it seems like you should always switch. But here's the paradox. No matter which envelope you start with, the same logic applies. This means that before opening either envelope, you should always plan to switch. But that creates an infinite loop, since if you switch, the same reasoning applies again, meaning you should switch back. So, what's wrong with this logic? Mathematicians and philosophers have debated different ways to resolve the paradox. 1. Faulty probability assumption. The mistake comes from assuming a 50% chance that your envelope is the smaller one. In reality, the game isn't structured this way, so the math is misleading. 2. Undefined expectations. The expected value calculation only works if we know how the amounts were chosen, but since the envelopes are chosen arbitrarily, we don't have enough information to apply this formula. 3. No real advantage. Some argue that switching doesn't actually change your odds in a meaningful way, since you always return to the same paradox. The two envelopes. Paradox reveals flaws in decision theory, probability, and mathematical expectation. It's a great example of how logic that seems sound can lead to absurd conclusions.